Hello guys, today we are discussing some basic numericals on modes of heat transfer, that is conduction, convection and radiation. Let's go.
Here we see that there is one example, and now we are going to solve this example. So what will be the given? First try to make one rough diagram. Calculate the heat transfer rate. What we need to find Q rate per unit area, Q by A, through a copper plate of 0.045 meter of thickness. 45 meter of thickness, that's D will be equals to 0.045 meter, whose one phase is maintained at a temperature. Suppose this phase is maintained at a temperature of 350 degrees Celsius. Suppose T1, consider this temperature as T1, will be 350 degrees Celsius. And the other phase, suppose this will be the other phase, is at a 50 degrees Celsius, that is T2 is at 50 degrees Celsius. Thermal conductivity of copper material, its thermal conductivity is given as 370 watt per meter degree Celsius. Now we know from Fourier's equation for heat transfer through wall is Q is equals to A Ka into T1 minus T2 upon B. Here they ask you Q upon A. So it will be equals to K into T1 minus T2 upon B. It will be equals to, put the values of known, that is K, T1, T2 and B. Here K is 370 into T1. T1 is 350 minus T2. T2 is 50 divided by B. B is 0.045 meter in meter. So Q by A will be equals to simply what you have to do, take a calculator and find that is 350. First we will solve the bracket, minus 50 into 370 into 370 divided by 0.045. we will get 2466.67 watt per meter square. This is the final value of heat transfer per unit area. Next example. Now here given is a hot plate. Suppose this will be the plate. Consider this will be a 3D view with 1 meter length and 1.5 meter will be the hot plate of 1 meter length and 1.5 meter breadth. Then they have given that this surface is maintained at 300 degree Celsius, that is surface temperature is 300 degree Celsius. Air at 25 degree, air, that is T infinity, surrounding temperature is 25 degrees Celsius, blows over a plate. If the surface heat transfer coefficient is that is convective heat transfer coefficient is 20 watt per meter square degree Celsius. Find the rate of heat transfer, the rate of heat transfer. Now, according to the Newton's law, according to Newton's law, Q is equals to H into A Ts minus T infinity. So, simply we know H, we know A, we know Ts, we know T infinity, we will get Q. So, Q will be equals to H. H will be equals to 20 into A. Area of this plate is length into its breadth into 1.5 into Ts minus T infinity. Here Ts is 300 minus T infinity. T infinity is 25. We will get Q by simply using a calculator. Here they have given, first we will solve the bracket, that is 300 minus 25, 300 minus 25 into 1 into 1.5 into 20. It will be equals to 8,250 watt. This will be the rate of heat transfer. Discussing example on radiation. So here they have given a filament of a filament of Q is equals to 100 watt light bulb. Suppose this will be the bulb radiates energy into the enclosure. This will be in one enclosure which is at temperature, suppose T1 of 350 degree Kelvin, which is at 350 degree Kelvin. Both the bulb and enclosure act as an black bodies. Both are act as an black bodies. Determine the temperature of bulb, that is, suppose its temperature will be T2. So what we need to find? Find T2 of the bulb if it is of 0.12 mm in diameter. So its diameter is 0.12 mm, that will be equals to 0.12 into 10 raised to minus 3 in meter, and 5 cm long. Its length is 5 centimeter, that is 5 into 10 raised to minus 2 meter. This length is 5 centimeter and its diameter is 0.12 mm. So according to Stephen Boltzmann's law, Q is equals to sigma A into T2 raised to 4 minus T1 raised to 4, because here heat is emitting light bulb. This bulb will emits radiation to the surrounding. So T2 is higher, so we can write T2 raised to 4 minus T1 raised to 4. So first we will calculate the area. Area will be equals to pi d into L. Area of cylindrical surface is pi d into L, that will be equals to pi into d. Its diameter is 0.12 into 10 raised to minus 3 into its length 5 into 10 raised to minus 2. We will get area. Now we are calculating it by using a calculator. So 5 into 10 raised to minus 2 into 0.12 into 10 raised to minus 3 into pi, we will get area as 1.80 8 into 10 raised to minus 5 meter square. Now we know Q sigma, that is Stephen-Boltzmann constant. Its value is Stephen-Boltzmann constant is 5.67 into 10 raised to minus 8. We know we wants to find T2. They have given T1 as 350 in Kelvin, means it is in already in absolute. Okay, so Q, that is 100, will be equals to sigma, that is 5.67 into 10 raised to minus 8 into A, area will be equals to 1.88 into 10 raised to minus 5 into T2, T2 raised to 4 minus T1, T1 is 350 raised to 4. Now what we will do, T2 raised to 4 minus 350 raised to 4 will be equals to 100 divided by 5.67 into 10 raised to minus 8 into 1.88 into 10 raised to minus 5. So we will get T2 raised to 4 minus 350 raised to 4 will be equals to 100 divided by area divided by 5.67 by 10 raised to minus 8, we will get 9.356 into 10 raised to 30. So we are adding this 350 in this, we will get T2 raised to 4 will be equals to this plus 350 raised to 4 will be equals to 9.358 into 10 raised to 13. So we will get T2 will be equals to this answer raised to 1 by 4. We will get T2 as 3110.25 degree Kelvin, that is 3110.25 degree Kelvin.
So we have discussed basic numericals. If you like these numericals, please do like and subscribe. Thank you.